To most, Arizona climate seems pretty straightforward.
That being deserts, deserts, and more deserts.
So it may come as a surprise to you, unless you're watching us because you're in my class, that there is indeed one other climate. That being, drum roll please, and wouldn't you know it, mountains are completely different to deserts. But how and why are they different? Now there are some obvious reasons, but I'm here to explain everything. So without further ado, this is... To fully understand the reasons for them being completely different, we first need to understand how they form, which brings us to tectonic plates. Now, what is a tectonic plate? Tectonic plates are the upper layers of the Earth's crust that, due to the constantly spinning core, are constantly shifting around, causing earthquakes, volcanic eruptions, and is how Pangea keeps splitting up and coming back together. Fun. Now, how does this relate to how deserts and or mountains are formed? It's actually pretty easy to explain. If the edge of two tectonic plates were to go into each other, like by hands, it would cause the land to rise, forming mountain ranges. And wouldn't you know it, Flagstaff is part of a mountain range. And since Phoenix is flat, it can be assumed that it does not lie on the edge of a tectonic plate. With that taken care of, now it's time to cover why mountain ranges are the ultimate airbenders. Imagine mountain ranges as walls as they block the path of wind and rainfall, resulting in a dry side and a flourishing side. This is why mountains either appear to be covered in trees and other forms of life, or really rocky looking, depending on where you look at them. Luckily for Flagstaff, it falls on the livelier side of this particular mountain range, but besides receiving a large amount of rainfall on one side, that isn't the only effect on the weather mountains have. They also have a large impact on weather patterns everywhere. As one may remember from the elementary school science class, objects of motion wish to stay in motion. This also applies to wind. As the winds blow, they can't just stop once they reach the mountains, but they can't go through it either. So the air current begins to go along the mountain range. This sends the rain to other locations, giving them consistent rainfall. That being said, Phoenix is unfortunately on the side of the mountain range that ends up dry. Now the reason why the different weather patterns occur has been covered. It is time to cover temperature, the most apparent difference between these two areas. And while weather does help with temperature control, it's not the only contributor to the group project. So let's see what the other members are and what they bring to the table. First off is pressure. While many seem to think that only heat can create pressure, but pressure is also capable of creating heat. This is best seen in stars and the Earth's core, as both experience an extreme amount of pressure, resulting in the magma core and the plasma state. This can also be seen, though to a lesser extent, in Phoenix. As the elevation there is much lower than in Flagstaff, the area is experiencing more pressure. This can be seen if you were to take a plastic bottle and take it down to Phoenix from Flagstaff, as it collapses in on itself. That covers everything that my research has come up with. I again apologize for my voice. I'm currently sick as I'm recording this, but I really hope that you all enjoyed it, especially if you're the professor. But anyway, have a good rest of your day.